So looking at the test case, or looking at the program, the piece that I was just talking about was here. It says how many pavers will your customer need? First, calculate the patio area. There are many patterns for putting down pavers. Rather than lay out the exact pattern, allow 10% more square feet for pattern matching and waste. So that pattern matching and waste, that's going to apply, and the 10% is going to apply to the paver, not to the other parts of the calculations. So if we're looking at the test cases, the test case I'm going to go over is going to be this one here. Patio dimensions 12 by 15 feet. And we need to make sure that we calculate for all of these. And so the hand calculations can be like a question that was asked earlier. You can use this Word document and just type them here at the bottom. You can do them in Excel. You can handwrite them and scan them in, whatever you need to do. And then you just turn that in on Blackboard under the test case, P1 test cases. Okay, so I'm going to type them up as we go through here. So first thing first is we know that we have 12 feet by 15 feet as our test case. That's the one we're going to look at here. So the first thing that we're told to calculate is the area, right? What happened there? So if we look here, first thing is calculate the area of the patio. So in this case, that's actually pretty straightforward, except I'm going to do one thing different, and I'm going to convert it to inches because it's going to make the work a little bit easier. So I'm going to say area of patio in square inches, or let's just say inches squared, like that. So that's going to be equal to 12 feet times 15 feet. Actually, I'm going to use this as times because that's what we're going to use in C++. And then times 144. So that's for square inches, right? Since it's square inches, it's 12 times 12, so 144. So if you do that, your area that you're working with is going to be 25,920 inches square. So that's number one right off the bat. Now two, we want to know the number of pavers, or number of bricks. So I'm going to say number of pavers. And this is going to be the kind of the base number. Whoa, what happened there? So that's going to be the 25,920 that we had divided by 8 times 4. And where does that 8 times 4 come from? It comes from the size of a paver, which is 8 inches by 4 inches. So that's why I converted to inches. Makes this calculation a little bit easier. So divided by 8 times 4 divided by 12. I'll go and put 8 times 4 down here, but it's divided by 12, right? So if I do that, that's going to give us 810 pavers. 32, yes, sorry. 8 plus 4 is 12. Yeah, so 32 square inches. Thank you, James. So then, now we're going to figure out what our extra pavers are, and that's going to be the 10%. So that's the 10%. And that's pretty easy, right? That's just what we had above, which was 810 pavers times 0.10, which is going to be 81. So then, our total number of pavers is going to be equal to that 810 plus 81, which is going to be 891 pavers. So, looking back at our test cases, calculate number of pavers, that's number 2. So far, so good. Now we're going to calculate the number of bags of sand and scoops of gravel needed. So a little bit more calculation intensive. So, make this bigger. There. So first we're going to find our gravel volume. So the gravel volume is going to be the area, which is 25,920 times 4. And that comes from this line right here, the volume of gravel needed for the base is enough to provide a base the same area and 4 inches deep. Okay, so that volume will be inches cubed, right? So 103,680 inches, cubic inches, or inches cubed. Now sand volume is going to be the 25,920, and that one in the spec says it's 1 inch deep, so times 1 are just the same, right? So 25,920 inches cubed, or cubic inches. Okay, so now we want to know the gravel volume in cubic feet. So in order to get that, feet cubed, we're going to take that number that we had, 103,680. We're going to divide that by 12 times 12 times 12, or 1728, because that's inches, or yeah, inches cubed. So it's 1728 cubic inches per cubic foot. So that's going to give us 60 feet cubed. Same thing for the sand volume in feet cubed. That's going to be 25,920. Put the comma like I've been doing. 25,920 inches cubed divided by 1728, or 15 feet cubed. Okay, then figure out how much gravel. So the number of scoops of gravel is going to be that number of 60 feet cubed. Remember to include your units in the calculations as well when you turn this in. And that's going to be divided by 8.5 cubic feet, which is going to give us 7.05882353 scoops. And we're going to round up. So that's going to give us 8 scoops. And the reason we have 8.5 is, again, if you look at the spec, we have 8.5 cubic feet per scoop. Similarly, we're going to have 0.4 cubic feet of sand per bag. So looking at that, number of bags, this will be bags of sand. So this was number of scoops of gravel. So number of bags of sand is going to give us that 15 feet divided by the 0.4 cubic feet. So that's going to be 37.5 bags. Again, round up. So that's going to be 38 bags of sand, 8 scoops of gravel. Now we have number 4, right? In the test cases, we asked for number 4, calculate. Oh wait, number 3, calculate the number of bags of sand and scoops of gravel needed. So that's number 3. Now on to number 4. Almost there. So now we want to do the cost of the pavers. How many pavers did we have? We had 891. What's the cost of a paver? It is, again, going back here, 45 cents. So 0.45. Our pavers are going to be $400, are going to cost $400 and 95 cents. Cost of the gravel is going to be number of scoops of gravel times the cost per scoop. Cost per scoop is $5.95 right there. $47.60. And cost of the sand, we had 38 bags. Each bag is going to cost, I'm not going to go over the spec now, but $3.97 per spec. Oops. $3.97, which is going to equal $150.86. That's number 4. Now number 5 is total cost. Add those up. So 400.95 plus 5.95 plus 3.97 is going to give us a cost of $599.41. That's it. So you're going to do the same thing for your other 2 examples. This was 12 by 15 feet, so that's the first test case. Follow the same steps for 10 feet by 6 feet and 16 feet by 14 feet. If you looked at some of the SuncatByte, those steps could be considered an algorithm. So if you're thinking about an algorithm, you generalize these steps, and that's how you can turn this into a program. One thing to note, if you do end up with a decimal here on number of pavers, you round up just like we did below for the number of scoops of gravel and number of bags of sand. Any questions? None? Where did I get the 1728? 1728 is 12 times 12 times 12. So when we're looking at cubic feet, so if we had 100 up here, right? 103,680. Right here. We had 103,680. That was cubic inches. If I need to convert to cubic feet, I have to use basically inches three times. So you can also say 103,680 divided by 12 divided by 12 divided by 12. Or you can just divide it by 1728. So it's how you convert from cubic feet to cubic inches. Good there? Good. Any other questions? Yes, so in the spec, when it asks for a goodbye message, yes, just a short statement. Basically, you can just say goodbye, thank you for using our calculator, or something like that. So the question was for the goodbye message, is it just a short statement? And that was my answer. You're welcome. Other questions? Go ahead, Nathan. One second. Where's my screen? There I am. Is it best for you to convert right away during the first step, or you can do it later? It's up to you. So I found it easier to convert to inches right away, but if you're getting the same result, way works. No problem. Yes, this is due on Thursday, and the deadline for almost everything is going to be the end of the day, which is 11:59 p.m. I think it should show you the time in Blackboard as well, but you're welcome. All right, I'm going to stop the recording now.